Hello and welcome to Take 18 of Mr. Hill's online review for this coming week's Patterns and Functions Assessment for Stephen Decatur Middle School. One of the big things is tables. Anytime you're looking at tables, you want to look at what your rows are telling you, and of course you want to pay close attention to your columns. Any of the questions could have you comparing a single day, could have you comparing genders, could have you adding up totals. That's all that you're doing with tables. Read carefully. Linear versus nonlinear. You are looking for something that makes a single solid straight line. If it doesn't on the graph, then it's not linear. With regard to the equation, it has to be of the form y equals mx plus b. Even if it's got a fraction in it, that's okay. However, exponents, nonlinear if it has an exponent to it. In our patterns, you look for one of two things. You're either adding the same amount or subtracting the same amount each time. That's our arithmetic sequences. We like those. Those are nice and easy. Or it could be that you're multiplying. Now, I know we've worked with a lot of different types of patterns over the past few weeks. However, those are the only two that you're really going to see on the test. You either look for something to add or subtract each time, or you look for something to multiply each time. One of the huge components on there has to do with graphing and slope. Anytime you're looking at slope, in the equation that we have here, it's y equals mx plus b, which of course is always going to be the coefficient on x. So it's always going to be the number. That's a terrible error. That's even worse than the green one, huh? It's always going to be the number that's in front of x. If you have it in a word problem, it's got to be some type of rate. So he starts with 2 cupcakes. Well, that sounds like an initial amount. So that's going to be our y-intercept. And then 4 cupcakes every 5 minutes. Well, that's simply the fraction 4/5 cupcakes per minute. That's our constant rate of change. Sounds delicious. Anytime that you're looking at slope, especially with regard to word problems, especially with regard to in the context of problems, it's always going to be the rise over the run. So it's going to be the change in y over the change in x. Now, you may have to figure out what exactly the x is. What is your independent? Your x is your independent. Figure out which one is telling the other one what to happen. In other words, which one controls the other. You may have to figure that out, but it's always going to be rise over run. With regard to proportions and unit rates, for that, you're going to set up proportions. I bought 6 Matchbox cars for $10. So I'm going to say Matchbox cars over dollars. Or you could flip it and make it the other way. But what you need to do is write yourself one of these over on the side to help keep you straight. So if I have 6 Matchbox cars for $10, that equates to 8 more Matchbox cars for how many? And then, of course, to solve this, we are simply going to cross multiply. And we get 80 equals 6x. You divide by both sides by 6. And, of course, my good luck works out quite nicely. $13.33 is the amount that it's going to cost for 8. And that sounds reasonable given that 6 costs 10. As for graphing, you're going to see a lot of different ways in which we're graphing. This is our slope-intercept form. We've talked about this a few times. The m is, of course, your slope. And then the b is your y-intercept. Has to be solved for y. If y is not by itself, then you can't use this method. Excuse me. But if y is on one side of the equal sign by itself, then in front of x is your slope, and then b, of course, is your y-intercept. That's where you start on the on the y-axis. For a table of values, that's something that probably looks something similar to this. My favorite numbers are -1, 0, and 1, only because they cancel out. That's kind of our default method for graphing. If you forget, then use that. And then for x and y-intercepts, that's where you're going to plug in 0 for x and 0 for y. That's especially nice if you have some problem where, for example, 3x plus 5y equals -15, because 3 and 5 both go evenly into -15. So it's going to cancel. It's give you nice numbers. So our y-intercept there would be -3. And our x-intercept, as we plug in 0 for y, will give us -5. You would plot those ordered pairs on the on a coordinate plane, graph it, and you're done. And then lastly, scatter plots. You're going to see scatter plots in about 3 or 4 different lights. But the big key is what's right here. This is the part that's always there. Title, axis, label, even intervals, 2 variable data if you have to create one. And then I can't stress this enough. Read your axes and the data carefully. You're either going to be given multiple scatter plots and a single table, or multiple tables and a single scatter plot. And the key to doing that successfully is to read carefully. That's the only way that it's going to work out for you. All right, hopefully this has been helpful. It's taken a lot more time than I wish for it to work, but hopefully, above all else, it is useful. Thanks.